We're going to talk, but what exactly are vectors? When we talk about vectors, we're talking about quantities that are represented by arrows. So for example, I can draw a vector this way. This we can call vector A, for example. Now vector A, which is the arrow that I have drawn here, can be represented by two values, which is the magnitude, which we represent with this symbol, which would be the absolute value of vector V. In this case would be vector A. This is the magnitude. And also we can represent this vector by its direction. So notice how vectors are quantities that have both of these values, which are magnitude and direction. So when we have a vector represented by the magnitude and the angle which it is pointing at, we call these the polar coordinates. Now we can represent the same vector A with the same arrow, but in this case, I'm going to represent it not by its polar coordinates, but by its Cartesian coordinates. So you might remember this word from your Cartesian planes, and this is exactly what we're going to represent this vector by. So for example, we have vector A, we have the same arrow, but this time I'm gonna have two quantities which represent the horizontal component of the vector called I, or the I component, and we're gonna have the vertical component of the vector, which is called the J component. And together we can represent this vector. So why would we have two languages per se to represent the same thing? Well, you will notice in your physics course that these two notations can be used in different scenarios. For example, when we want to add or subtract or perhaps multiply vectors, you will find that the Cartesian coordinate is the appropriate coordinate system to use. So if we have two coordinate systems, we should be able to jump from one coordinate system to the other. There are several formulas you can use to jump from polar coordinates to Cartesian coordinates and vice versa. So for example, let's say you have a vector that is written in its polar coordinates. So you would have the magnitude and you would have the angle in which this vector is pointing at. So in order to obtain the I component and the J component, you can use the following formulas. So for the I component, you can use the absolute value, the magnitude of the vector times the cosine of the angle. And for the J component, or the vertical component of the vector, you can use the magnitude times the sine of the angle. In this way, you will get the same vector, but represented with its Cartesian coordinates. Likewise, we can represent the vector from Cartesian coordinates to polar coordinates. We can change these values by obtaining the magnitude and direction through the I component and the J component. So for example, if you would want the magnitude of the vector, you would use the Pythagorean theorem. So you would do the horizontal component squared plus the vertical component squared. And this would make sense because if you see here in the Cartesian coordinate vector triangle, you have to notice that this is a right triangle in which you can find the hypotenuse of the triangle by using the Pythagorean theorem. Also, if you want to find the reference angle of the vector, you can do so by using this formula, which is the tangent inverse of the J component divided by the I component. Okay, so now that we understand more about both coordinate systems, the polar coordinate and the Cartesian coordinate system for vectors, we can do the following problem. So in this problem, we have vector v has the initial point 3, 2 and the terminal point 6, 8. First of all, we're asked to find the component form of vector v. So in order to do so, we can graph the vector in a coordinate plane. So I'm gonna draw my coordinate plane right here. And we know that the initial point would be 3, so let's draw it right here. This would be 3, 2. And the terminal point would be 6, 8. So it would be around, let's say, here. So the vector always points in the direction of the terminal point. So notice how we always have a magnitude and direction of the vector, which we will find. But here it's very important to recognize the difference between the initial and the terminal point. So now that we have these values, we're asked to find the component form of vector v, which is what we saw in the Cartesian coordinate system. So for the horizontal value of this vector, which would be represented right here, this would be the component I. Now, if we notice that the terminal point has an x value of 6 and the initial point has an x value of 3, we would find the horizontal component of this vector would have a value of 6 minus 3. So 6 minus 3 in the I direction, which is the x direction. And we can do the same with the vertical or the y values of these points. So we find that the terminal point has a y value of 8 and the initial point has a value of 2. We can subtract these values and get what the vertical component, which would be represented right here, would be. So 8 minus 2 in the j direction. So our first answer would be 3i plus 6j. This would be our answer for the first question. Now for the second question, says, determine the magnitude of vector v. So in order to do so, we can use the formulas that I gave you previously. Remember that the magnitude of vector v can be found by using the Pythagorean theorem. So it would be 3 squared plus 6 squared. So we would get the square root of 9 plus 36, which would give us the square root of 45. This would be our answer for letter B. And finally, to find the direction of the vector, we can find the angle by using the other formula, which would be tangent inverse of the j component, that is 6 divided by 3. So this would give us tangent inverse of 2, and we can actually plug that in our calculator. Remember to have your calculator in degrees. So this is very, very important. You will see that there is a D value in my calculator at the top that tells me that my calculator is actually in degrees and not radians. So this answer gives me 63.43 degrees of direction. Okay, so now we're going to be asked to perform an operation of vectors. In this problem, we have that vector x has the following component form. And in this case, you will find that the vector x is given in its Cartesian coordinate form. And vector y has a magnitude of 10 at an angle of 50 degrees with respect to positive x. So we're given two vectors, and we're asked to find the sum and the difference of both. Remember that in order to add or subtract vectors, it is easier to do so by changing both vectors into their Cartesian coordinate forms. So the x vector is no problem. We already have this vector in its Cartesian coordinate form. But the y vector is given in its polar coordinate form, which would be 5. We have a magnitude of 10 at an angle of 50 degrees with respect to the positive x. So in order to change this into their Cartesian coordinate forms, we already said that x is already in that form. We just leave it alone. But the y vector, we can change it by using the formulas previously given. So remember that in order to find the x component or the I component of the vector, we can use the formula which multiplies the magnitude of the vector, which would be 10, times the cosine of the angle, which would be cosine of 50 degrees. This would give us the horizontal component of the vector. And the vertical component of the vector would be 10 times the sine of the angle given. So in other words, we can use the calculator in order to find both components. So 10 cosine of 50 would give me 6.43. Let's round this number to 3 decimal places. So it would be 6.43i, and 10 sine of 50 would give me 7.66. So now that I have both vectors in their Cartesian coordinate systems, we can perform the following operations. So when we want to add both vectors, remember you can only add their horizontal components together and their vertical components together. So in order to do so, I'd like to write these as a normal sum. So I will write the x vector on top and the y vector on the bottom, which would be 6.43i plus 7.66j. And I would like to add both of these in order to get the sum of these vectors. Sometimes you will find that these operations will tell you that the result of this sum would be called the resultant vector, represented by r and an arrow above it. So in this case, we would add 6 and 6.43 in order to get 12.43 for the horizontal component of the resultant vector, and -8 plus 7.66, we can do that operation in the calculator to get that the vertical component of the vector would be -0.34. This is the answer of the sum of both vectors. And just like in the sum, we can actually subtract these vectors by doing the opposite. So I would like to copy and paste this operation right here. But I want the difference of both vectors, which means I would like to subtract vector y from vector x. So now the process is the same, but I would like to subtract the components of y from the components of x. So now the resultant vector would be 6 minus 6.43, which would give me -0.43 in the I direction or the x direction, and then -8 minus 7.66. This would give me -15.66. You can put a plus sign and then open a parentheses, or you can just place a negative sign in front and put the value assigned to that component. So this would be the answer for the difference of vectors.